Hey there, science explorers! Welcome back to School Subjects Online. Today we're diving into the exciting world of forces and motion. From the rush of a roller coaster to the simple act of walking, forces are behind it all. Ever wonder why that ball you threw eventually comes back down, or how a rocket blasts off into space? We'll learn about pushes and pulls, and how they make our world go round. We'll explore the different types of forces like gravity, friction, and magnetism. Get ready to become force and motion detectives, uncovering the science behind everyday events. So buckle up, get ready for some fun, and let's unravel the mysteries of forces and motion together. Why is learning about forces and motion important? Understanding them helps us understand how the world works. Engineers design amazing structures like bridges and airplanes using this knowledge. It helps us play sports better, ride bikes, and even walk safely. By learning about forces, we can design new inventions that can change the world. Let's start with gravity. Gravity is like Earth's giant hug, pulling everything towards its center. It's the reason why when we jump up, we always come back down, and why things fall to the ground when we drop them. Gravity affects everything in the universe. It holds the moon in orbit around Earth and keeps all the planets revolving around the sun. Without gravity, imagine everything floating around in space like lost balloons. So the next time you drop your pencil or see an apple fall from a tree, remember gravity at work. Now let's talk about friction. Friction opposes motion when two surfaces rub against each other. When you're running and want to stop, you slow down because of the friction between your shoes and the ground. Friction allows us to hold objects and walk without slipping. Imagine trying to hold a wet bar of soap. It's slippery because the water reduces the friction. Friction can be both helpful and a nuisance. It's helpful because it allows us to walk, write, and light a match. But it can also cause wear and tear on things like our shoes and car tires. Try rubbing your hands together really fast. What do you feel? Heat. That's the energy generated by friction. So friction isn't just a force, it's also a source of energy. Understanding friction helps us in everyday activities and designing better tools and machines. Magnetism, the force of attraction and repulsion. Magnetism attracts or repels certain materials, especially iron and steel, without even touching them. Every magnet has two poles, a north pole and a south pole. Opposite poles attract and like poles repel. Magnets are incredibly useful in our daily lives, found in everything from refrigerators to computers and MRI scanners. Earth itself is like one giant magnet with a magnetic field that protects us from harmful radiation from the sun. And that's how compasses work too. The needle of a compass is a tiny magnet that aligns itself with Earth's magnetic field, always pointing north. Magnetism is a fascinating force that plays a crucial role in our technology and navigation. Forces in action, putting it all together. We've learned about gravity, friction, and magnetism. These forces work together in incredible ways. Think about a bouncing ball. When you drop it, gravity pulls it down towards the ground. When the ball hits the ground, friction slows it down, and the ground pushes back up on the ball, causing it to bounce back up. As it bounces back up, gravity slows it down until it reaches its highest point, and the cycle repeats. This interplay of forces is what makes the ball bounce. Or consider riding a bike. You push on the pedals, creating a force that turns the wheels. The friction between the tires and the ground allows the bike to move forward, and gravity keeps you grounded and helps you control the bike. Forces are everywhere, constantly interacting and shaping our world. Newton's first law, the law of inertia. An object remains at rest or moves in a straight line unless acted upon by an external force. A soccer ball won't move unless kicked. This is inertia. Heavier objects have more inertia, making them harder to move. When you stop pedaling, your bike slows down due to friction and air resistance. In space, without air resistance, astronauts keep moving until they hit something. Newton's second law of motion gives us a formula to calculate the effect of forces on objects. Mathematically, it's expressed as F equals sine ma, where F stands for force, m is mass, and a is acceleration. Imagine you're pushing a shopping cart. If the cart is empty, it's easy to push and accelerates quickly. But if it's full of groceries, you need to push much harder to get it moving. In another example, kicking a lightweight ball takes less effort than a heavy bowling ball. Car engineers use Newton's second law to design safer vehicles by calculating forces in crashes. That's Newton's second law in action. Newton's third law of motion states that for every action, there is an equal and opposite reaction. When one object exerts a force, the second object exerts an equal and opposite force back. Push down on a diving board and it pushes you up. Rockets launch by pushing gases downward, causing an upward reaction. Blow up a balloon and let it go. The air rushes out and the balloon flies off. When you step forward, your foot pushes back and the ground pushes you forward. Birds push air down with their wings and the reaction lifts them up. Every action creates an equal and opposite reaction, balancing forces in our world. Let's wrap up our exploration of Newton's laws of motion with some fun examples and real-life applications. These laws help explain many everyday activities. Take sports, for example. When a basketball player throws a ball, they apply a force that makes the ball accelerate towards the hoop. The ball eventually comes down due to gravity, and when it hits the backboard, it bounces back with an equal and opposite force. Roller coasters are a thrilling application of Newton's laws. As it speeds down, gravity accelerates it, and as it twists and turns, the tracks push the coaster in different directions. Another cool example is how cars work. When you press the gas pedal, the car's engine produces a force that accelerates the car forward. When you jump and land on a trampoline, you push down on the surface. The trampoline then pushes you back up with equal force, sending you into the air again. These laws are all around us, from playing sports to driving cars, and even in amusement park rides. Understanding Newton's laws helps us appreciate the science behind these activities and see the world in a whole new way. Hey there, builders and inventors! Have you ever wondered how people moved those giant stones to build the pyramids? Or how those massive ships get lifted out of the water? The answer is simple machines. These clever tools have been making life easier for centuries. Simple machines are basic mechanical devices that change the direction or magnitude of a force, making it easier for us to do work. Work, in the science world, means using force to move something over a distance. Simple machines don't necessarily reduce the amount of work we do, but they make it feel easier by changing how we apply the force. So, put on your thinking caps, and let's explore the fascinating world of simple machines. We'll uncover the secrets behind 6 amazing tools: the lever, pulley, wheel and axle, inclined plane, screw and wedge. First up, let's meet the mighty lever. A lever is a rigid object, like a bar or a plank, that pivots on a fixed point called a fulcrum. Think of a seesaw. The middle part is the fulcrum and the boards on either side are the arms of the lever. When you push down on one end of the lever, it creates an upward force on the other end, allowing you to lift or move things with less effort. The closer the object is to the fulcrum, the easier it is to lift, because you're applying a smaller force over a longer distance. Levers are everywhere. Scissors, pliers, even a simple door handle. They're all levers in action. They help us cut, grip, pry, and lift things we couldn't manage with just our bare hands. Next, let's hoist the sails with the pulley. A pulley uses a grooved wheel and a rope or cable to change the direction of force and make it easier to lift heavy objects. Think of raising a flag on a flagpole. You pull down on the rope, but the flag goes up. Pulleys are especially helpful when lifting things vertically. They can be used to lift heavy construction materials, move furniture, and even rescue people from high places. By changing the direction of force, pulleys make it possible to lift things that would be impossible to move otherwise. Now let's roll into action with the wheel and axle. This dynamic duo reduces friction, making it easier to move objects. The wheel rotates around a central rod called the axle. Wheels and axles are essential for transportation, moving people and goods efficiently. Next, we'll take the easy way up with the inclined plane. This simple machine is a flat surface tilted at an angle, like a ramp. It's easier to push or pull something up a ramp than to lift it straight up. Finally, let's get sharp with the wedge. A wedge is 2 inclined planes joined together, forming a sharp edge. It's used to split, cut, or lift objects by applying force to its wide end. Now that we've met our simple machine superheroes, let's talk about their secret weapon: mechanical advantage. Mechanical advantage is the ratio of the output force produced by a machine to the input force applied to it. In simpler terms, it tells us how much easier a machine makes it to do work. For example, a lever with a mechanical advantage of 2 means that you can lift an object twice as heavy with the same amount of effort. That's like having super strength. Each type of simple machine has its own way of calculating mechanical advantage, but the main idea is the same. They make it possible to do more work with less effort. They do this by either changing the direction of the force, increasing the distance over which the force is applied, or both. Understanding mechanical advantage helps us appreciate the power of simple machines and how they make our lives easier. From lifting heavy objects to splitting wood, and even just opening a bottle of juice, these ingenious tools are constantly working behind the scenes, proving that a little bit of cleverness can go a long way. So the next time you encounter a simple machine, remember its hidden superpower, mechanical advantage. Hold on tight, speed racers, because we're about to explore how forces can change the speed of objects. Remember that force is like a push or a pull. When a force acts on an object, it can either speed it up, slow it down, or keep it moving at a steady pace. Imagine you're pushing a toy car across the floor. The harder you push, the faster the car goes, right? That's because you're applying more force, which causes the car to accelerate or speed up. But what happens when you stop pushing? The car gradually slows down and eventually comes to a stop. That's because another force is at work. Friction. Remember, friction opposes motion, so it acts like a brake, slowing the car down. Forces can also keep objects moving at a constant speed. Think about a car cruising down the highway at a steady 60 miles per hour. The engine is providing a force to overcome friction and air resistance, keeping the car moving at that speed. So whether it's a gentle breeze pushing a sailboat or a powerful rocket engine propelling a spacecraft, forces are the driving force behind changes in speed. Get ready to steer your way through this section as we discover how forces can change the direction of objects. Just like a captain steers a ship, forces can guide objects along different paths. Think about playing soccer. When you kick the ball, the force of your foot sends it soaring through the air, but the direction the ball travels depends on how you kick it. Kick it straight on, and it goes straight. Kick it at an angle, and it curves through the air. Forces can also cause objects to change direction by making them turn or rotate. Imagine spinning a basketball on your finger. The force you apply with your hand causes the ball to spin, changing its direction constantly. Even something as simple as turning a doorknob involves forces and direction. When you twist the knob, you apply a force that makes it rotate, which then moves the latch and opens the door. So, from the graceful arc of a basketball to the precise movements of a dancer, forces are the choreographers of motion, guiding objects along their designated paths. Get ready to be amazed as we explore how forces can actually change the shape of objects. Forces are like invisible sculptors, molding and transforming the world around us. Think about squeezing a lump of clay. The force of your hand changes its shape, molding it into different forms. The same principle applies when you blow up a balloon. The force of the air inside pushes outward, stretching the balloon and changing its shape. But forces don't always have to be dramatic to change the shape of things. Even small, continuous forces can have a big impact over time. For example, the constant force of gravity pulls on our bodies throughout our lives, which can affect our posture and bone structure as we grow. And have you ever noticed how a tree's branches grow in the direction of the prevailing wind? The force of the wind actually shapes the tree over time, bending its branches and influencing its growth pattern. So from the majestic formations of mountains carved by glaciers to the delicate curves of a flower molded by the wind and rain, forces are the master artists of our world, constantly shaping and reshaping the landscape around us. Wow, we've covered a lot of ground today, explorers. From the invisible pull of gravity to the mighty power of simple machines, we've journeyed through the incredible world of forces in motion. We've learned that forces are everywhere, constantly at work, shaping our world and influencing everything we do. Think about it. Every time you take a step, ride a bike, or even just drop a pencil, you're witnessing the laws of physics in action. Understanding these laws gives you a superpower, the power of knowledge. You can now explain why things move, how they move, and what makes them stop. You can identify simple machines all around you and understand how they make work easier. But our exploration doesn't end here. The world of forces and motion is vast and full of even more amazing discoveries waiting to be made. So keep your curiosity alive and your eyes open to the wonders of science all around you. Remember, science isn't just about memorizing facts, it's about asking questions, exploring, and having fun discovering the answers. Try some of the experiments we talked about today at home or in the classroom. See if you can build your own simple machines or design an experiment to test the laws of motion. The possibilities are endless. If you enjoyed today's adventure into the world of forces and motion, give this video a big thumbs up. Share it with your friends and family and spread the excitement of science. And don't forget to subscribe for more fun and educational videos. Until next time, keep those scientific minds buzzing and never stop exploring the wonders of the world around you. See you soon.